hopefully. There we go. All right. So today is all about 5.4 isosceles triangles. And so today we want to be able to use something called the base angles theorem and the converse of the base angles theorem to find missing sides and angles on isosceles triangles. And then we're also going to talk about how that we can extend this to equilateral triangles. Okay, so here we go. Find the dot cam. Great. 5.4. Oops. C-E-L-E-S. Isosceles is hard to spell. Also, this is a little bit blurry. I'm going to fix that real quick. Okay. So first we want to remember a couple of things about isosceles triangles and equilateral triangles. So remember, isosceles have at least how many congruent sides for isosceles? Remember? 2. And then we had equilateral. With all 3 congruent sides. And then we had equiangular. With 3 congruent angles. And then we briefly talked about how equilateral and equiangular go together. If something is equilateral, it is also equiangular. If something is equiangular, it is also equilateral. So that's going to come into play today. Okay. And so since these two are related, we might kind of wonder, well, if isosceles triangles have at least 2 congruent sides, would they also have 2 congruent angles? Or at least that's what I might kind of wonder here. And the answer is yes. If something is isosceles and has 2 congruent sides, it also has 2 congruent angles. And so that is called the base angles theorem. And so if we kind of think about the anatomy of an equilateral or a isosceles triangle. Okay. We're going to kind of label the parts of an equilateral triangle. This side right here is called the base. And the 2 sides that are the same are called the legs. So we have leg, leg, base. And then these 2 angles are called the base angles because they're the angles that are connected to the base. And then this angle up here is the vertex. So the angle that's different, that's not attached to the base, is called the vertex. So this is kind of the breakdown of an isosceles triangle. So when I refer to these different words, we want to know what we mean. So the legs, the vertex, the base angles, and the base. Okay. So then there's something called the base angles theorem. Okay. So the base angles theorem says if two sides on a triangle are congruent, then the angles across from those sides are also congruent. If two sides on a triangle are congruent, then the angles across from those sides are congruent. I'll wait a moment and let people catch up on writing here, and then we'll do an example. Okay. So for this first example, we are going to see, which one do I want to be first? Okay. We might be given a picture like this and asked what the other two angles are. Okay. So to figure out what the other two angles are going to be, then we need to notice that these two are the sides that are congruent. So if these are the sides that are congruent, these are the legs, and this is the base. That means the base angles are congruent to each other, the ones that are attached to the base. So these two angles would be the same because of the base angles theorem. So that's part of our answer. So now if I know that this one is 44 and this one is also 44, then we can just subtract off of 180. So I can go 180 minus 44 minus 44 and get 92. So then x equals 92. Okay. So that's one problem that we could see using the base angles theorem. Okay. And that's going to be a very common one that we'll see today on our IXL section. Another example is going to be very similar to this, just a slightly different picture. Or just a slightly different thing we're asked for. The picture might even look very similar. Okay. So on this one, the picture's similar, but this time these two sides are the ones that are the same, and this one is different. So these are the legs, and this is the base. So that means that these two angles are the ones that are the same. So if this one is x, then this one is also x. So there's a couple ways you can think of this one. You could add all three of these and set it equal to 180. So you can go x plus 52 equals 180. Or you could just kind of think in your head, okay, if I subtract 52 off of 180 and then cut it in half, that would give me both of my angles. Because that's essentially what we're going to do here. So if you would rather go, okay, 180 minus 52 and then divide by 2, that's one way you can do it. Or you can write out the algebra and do it that way. Either way here, I'm going to subtract 52 from both sides and combine my like terms to get 2x equals 128, I believe. Yes. And then divide that by 2 to get 64 degrees. So these two angles here would both be 64. So those are going to be two of our most common types of problems that we'll see today. One case where you have to make them both the same here and then subtract off of 180. Another case where you have two angles that are the same that you don't know. So you subtract the angle that you do know and then divide by 2. Okay. So those are our first two cases. Let's see. The next thing we're going to do here is we're going to extend this thing to equilateral and equiangular triangles real quick. So if I have this equilateral triangle, I know it's also equiangular. So that means that no matter what the side lengths are on my equilateral triangle, as long as they're all the same, my angles will all be the same. And the angles will always be the same thing no matter what equilateral triangle or equiangular triangle you're talking about. So let's solve for what those would be. So if these angles are all the same, they would each be x. So then I know that all three of these added together, x plus x plus x equals 180. So if I combine my like terms, 3x equals 180. And then I divide by 3 on both sides, so x equals 60. So that tells me that each angle in an equilateral / equiangular triangle is 60 degrees. So that's just a fact to tuck away for later. each angle in an equilateral or equiangular triangle measures 60 degrees. No matter what. So whether these sides are all 10 or whether they're all 100 or whether they're all 1,000, every time for an equilateral or equiangular triangle, the angles are always 60. Every single time. So that's kind of a convenient fact. Something that's nice and easy to use. So anytime you see an equilateral triangle, you can always label the angles as 60. And that kind of extends from this because if two sides are the same, then the angles that are across from them are the same. But these two sides are also the same. So, you know, then you get pretty much all of your angles being the same. And when they're all the same, they're all 60. So that's an extension of the base angles theorem. So that's a super convenient fact. Okay. Then the last thing we have to do today is talk about the converse to the base angles theorem. So the converse is just switching it around, saying instead of saying like we did up here, if two sides are congruent, then the angles are congruent. We're saying now for the converse, if two angles are congruent, then the sides across from them are also congruent. So that's what we're doing next. That's where we're headed here. The converse to the base angles theorem. Okay, so the converse says if two angles on a triangle are congruent, then the sides across from them are also congruent. All right, so here's our example. So I know these two angles here are the same. They are congruent. So since that's the case, what that tells me is that the sides that are across from them are congruent. So that means that this side right here is the one that's across from 36 degrees here. This one is the one that's across from this 36-degree angle. That tells me that these two are the same. So x equals 14. That's all there is to that one. The ones with the sides actually tend to be simpler because you're just directly saying that things are equal. So then the kind of the equiangular extension of this is if I know all my angles are the same, so let's say they're all 60, then if I know what one of the sides is, like let's say that one of the sides is 4, I know all my other sides because I know that that one is going to be the same as all of the others. Because all the angles are the same, so all the sides will also be the same. Okay. Any questions so far? Okay. I'm going to show 2 more quick examples. And then you guys are going to try a couple, and then we'll be done with notes. Okay. So another example. Sometimes we will see something involving an exterior angle with this, so I want us to know how to handle that as well. Okay. This will work, right? Yeah, okay. So the way that I would handle this one is to notice that we've got a linear pair going on here. Linear pair. So then I know that since it's a linear pair, they add to 180. So 180 minus 115, which gives me 65, is what this angle is going to be right here, 65. And if this angle is 65, then this angle is also 65. So then if you want to, you could also go 180 minus 65 minus 65 and get 50, which would go right here. So x is 50. Okay. Another way that you could do that once you figured out what goes here, once you figure out that this is 65, you could also go then 115 minus 65 because you know that this angle is 65 and these 2 angles add to this one. Either way you want to do it is fine. This is probably the way that's the most clear, that uses or that uses the most basic things that we know already. So we figure out what this angle is because it's a linear pair. And then we figure out what this angle is because these 2 angles are the same, and the angles in a triangle add to 180. So that's another style of problem that we might see. And then the last one that we might see is going to involve equiangular equilateral triangles. If you see something like this, and you're told that this angle is 3x, and you want to solve for x, what did we say that the angles in an equilateral triangle are? What's each angle on an equilateral triangle? 60. So if each of these are 60, then 3x equals 60. All right, so that's all we want to do on that one. I just wanted us to not get thrown off by the seeing 3x and only one angle represented there. Okay. All right, you guys are going to get 2 to try, and then we're going to move to our assignment today, which is only one IXL section. All right, so on this one, we're looking for x. On this one, we're looking for x and y. So take a couple minutes, try these. These look a lot like our first 2 examples. Just throwing that out there. And when you think you've got it, type pineapples into the chat. Pineapples, yes. Like apples would be funny, though. If you're checking your work on the first one, if you got 67, you are correct. And then if you got 106 degrees for y on number 2 and 37 degrees for x, you're on the right track there. So on this one, we had these 2 sides being the same, so the angles across from them are the same, the base angles. Since these are the legs and this is the base. So if these 2 are the same, they're both x, and x plus 46 equals 180, or you could think of it as 180 minus 46, and then divide that by 2 to get your 2 angles here. over here, these are our two sides that are the same, so the angles across from them are the same. So x is 37, since this one is also 37. Then you can go 180 minus these two angles, 37 and 37, and that gives you y, your other vertex angle here, which is 106 degrees. And then we're done. Okay, so I'm going to post the assignment, and then from there we'll maybe go over a couple of those, and those of you who are ready to roll can go on ahead and do it, and those of you who would like more examples, we can do more examples. Alrighty, so we have one IXL section today. Like I mentioned, it is K9 in geometry. It's called congruency in isosceles triangles and in equilateral triangles. Okay, so the beginning type of problem, you'll see two sides that are marked congruent. So we're supposed to recognize that the two angles that are across from them, these two angles in this case, are congruent. So this one is also 42. Similar idea here. These are the two sides that are the same, so these two angles will be the same. So this is also 30. Then we get to one that's a little bit more like, actually, this is exactly the same problem as our U try number 1, where we had 46 here. These two angles are the same because these two sides are the same. So 180 minus 46, cut that in half, gives you 67. And then we get the case where all the sides are the same, so all the angles are the same, so they would all be 60. And then likewise, if all of the angles are the same, all the sides will be the same. Okay, so you are free to go ahead and get started on this. If you have questions, feel free to come back to the Google Meets or ask any questions you have now. And then towards the end of the class, I will post the exit ticket.